All right. Today we are going on a tour of the most complex, most powerful, and let's be honest, the most mysterious object in the entire known universe. This thing, it weighs about 3 pounds, has the consistency of soft tofu, and it is generating your entire reality as we speak. We're talking, of course, about the human brain.
Okay, so let's just jump right in with a question for you. What do you think is the single most complex and powerful computer on planet Earth? And I'm not talking about some fancy supercomputer in a lab somewhere.
Well, the answer is actually sitting right there, between your ears. You're using it this very second, to see the screen, to hear my voice, and to piece all these words together. It's your brain, and we are about to pop the hood and see how this incredible machine actually works.
So here's our roadmap for the tour. We're going to start with the big picture, where the brain fits into the whole nervous system. Then we'll actually map out its major continents, the lobes. After that, we'll dive deep into its core machinery, see how its tiny cells talk to each other, and finally, we'll look at what happens when things, go a little haywire.
Okay, section 1. Let's kick things off with that big picture. The first thing you've got to get is that the brain doesn't work alone. Not at all. It's the command center, for sure, but it's the headquarters of this huge body-wide communication network we call the nervous system. See, this whole network is basically split into 2 major parts. You've got the central nervous system, or CNS. That's the mainframe, the big boss, just the brain and the spinal cord. Everything else, all the nerves stretching out to your fingers, your toes, your stomach, that's all part of the peripheral nervous system, the PNS. Think of these as all the network cables carrying messages back and forth from the mainframe to the rest of the building.
Now, what's really cool is that a huge part of this network just runs on autopilot. It's the autonomic system, and it's basically got 2 modes. You have fight or flight, which is like slamming on the gas pedal. It revs you up. And then you have rest and digest, which is the brake. It cools you down. This incredible balancing act is happening inside you constantly, without you ever having to think about it.
All right, now that we've got the lay of the land network-wise, let's zoom in on the main event, the brain itself. We'll start with that big, wrinkly outer part, the cerebrum. And for this part of the tour, we're going to treat it like a world map, divided into 2 big hemispheres and 4 huge continents, or lobes, and each one has a very specific job.
First up, those 2 hemispheres. Now, you've probably heard this before, right? The left side is generally your logic and language center, while the right side is more about creativity and seeing the big picture. And connecting them is this massive superhighway of nerves called the corpus callosum. And this is wild. In the rare cases where that bridge gets cut, you get these bizarre split brain situations where one hand literally doesn't know what the other is doing.
Okay, let's start exploring those continents. Right up front, behind your forehead, is the frontal lobe. This is the CEO of your brain. It's in charge of planning, making decisions, your personality, the whole shebang. It's also home to Broca's area, which is essential for you to actually produce speech. So you can imagine, damage here, it can totally change who you are as a person. Right behind that, we've got the parietal lobe. This is your sensory headquarters, and your brain's built-in GPS. It takes in all the signals for touch, pain, temperature, and it tells you where you are in the room. And if this part gets damaged, you see some really strange things, like someone might completely ignore the left side of their own body, as if it doesn't even exist. Now, tucked down on the sides, right by your ears, are the temporal lobes. And yeah, you guessed it, their location is a big clue. They're all about hearing. But they're also super important for memory and for understanding what people are saying, thanks to a spot called Wernicke's area. If that spot is damaged, you might hear me speaking, but the words would just sound like complete nonsense.
And wrapping up our tour of the lobes, way at the very back of your head is the occipital lobe. It has one absolutely massive job: vision. It takes all the raw data streaming in from your eyes and turns it into the rich, colorful world you see around you. I mean, think about that. Your eyes could be working perfectly, but without this lobe, you see nothing. It's all just black.
Okay, so that's the wrinkly outer layer, the cortex. But if we go deeper, underneath all that, we find the really ancient primal machinery that's basically running the whole show. These are the subcortical structures.
Let's do a quick roll call here. You've got the thalamus. Think of it as the grand central station for all your senses, directing traffic. Right below it, the hypothalamus is your body's thermostat, controlling hunger, sleep, you name it. The hippocampus is your memory maker. The amygdala is your emotional alarm system, especially for fear. And that little cauliflower-looking thing at the back, that's the cerebellum, making sure all your movements are smooth and you stay upright.
But how do all these different parts actually communicate? Well, for that, we have to zoom in. I mean, way, way in. down to the level of a single brain cell, the neuron. And you've got about 86 billion of these little guys in your skull. It's just mind-boggling.
And what's so cool is that a neuron's design is all about one thing: communication. The dendrites are like little antennas, grabbing signals. The cell body is the processor that decides if the message is important enough. If it is, boom, the axon, this long cable, fires the signal out. And get this, that cable is wrapped in something called a myelin sheath, which is like the rubber insulation on a wire, making the signal travel super fast.
So every single thought you have is basically this tiny electrochemical relay race. A chemical signal comes in, the cell body sums it up, an electrical pulse shoots down the axon, and that triggers the release of more chemicals to the next neuron in line. And here's the kicker. This whole four-step dance, it's happening billions upon billions of times every single second inside your head, right now.
So now that we have a basic map, we can start to understand what happens when some of that wiring gets crossed or communication breaks down. So let's do a little brain troubleshooting.
Just imagine this for a second. You know what you want to say, you open your mouth to talk, and the words come out, but they're just gibberish. A completely jumbled word salad. This isn't science fiction, this can actually happen.
What you're imagining is a condition called aphasia. Remember those two language spots we talked about, Broca's and Wernicke's areas? Well, if Broca's area is damaged, speaking is really hard and choppy, but you can still understand people. But if Wernicke's area gets hit, you get that word salad we talked about. The words flow, but the meaning is just gone.
Okay, or try this one on for size. What if you looked at your closest friend, your parents, or even your own face in the mirror, and you saw a complete stranger?
It's a truly fascinating condition called prosopagnosia. You might have heard it called face blindness. It's often tied to a problem in the right hemisphere, the side we said was responsible for more holistic processing. It's just an incredible example of how hyper-specialized our brain can be.
So you might be wondering, how in the world do we know all this stuff? Well, it's because we've developed this incredible toolkit for actually looking inside a living, working brain. CT scans are super fast, great for emergencies. MRIs give us these beautiful, high-def pictures of the brain's structure. And fMRI actually lets us watch the brain in action by tracking blood flow. And an EEG listens in on the brain's electrical chatter, which is key for things like seizures. All right, let's wrap this up with one final thought to chew on. Every single thing you see, feel, touch, and believe is built by this 3-pound organ in your skull. It is the architect of your entire world. And that leaves us with a really profound question, doesn't it? What happens to your reality if the architect is working from a faulty blueprint? It really just drives home how powerful and honestly how fragile this incredible machine in our heads really is. Thanks for coming along on this tour.